Hi everyone, welcome to 591 Lab. This is Cisco Certified Devnet Expert class. The certification number is 350901. Okay, firstly, let me introduce about 591 Lab. 591lab.com, pronounced as 591 Lab, is a top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Okay, today's question is referred to the exhibit. An application uses an API to periodically sign a large dataset. Based on the HTTP message sequence provided, which two caching behaviors are seen in the scenario? Option A. Message 3 and 5 are equivalent. B. A particular dataset was transmitted to the client in message 4. C. The 4 dataset was transmitted to the client twice. Option D. The dataset did not change during the scenario. Option E. The dataset changed sometime between message 4 and 5. Firstly, I will tell you more about HTTP message circuits. We have several ways to make a HTTP request and lead to HTTP message circuits. As like this method, firstly is API. API will include in some script, and the second one is UI activity. This behavior may be in browser, and HTML forms may be in browser, and the config file may be in the on server. Okay, HTTP method will change to HTTP1 package firstly, and the HTTP method includes the request line in the first line. Okay, here is the action, the HTTP action. Generally, we use get for read intent and post, put, patch for write purpose. Next is the header. Post is where this HTTP message visits to, and the content tabs is what kind of message of the request body. There are many options in HTTP head, but we will still keep focus on message circuits. Okay, the last one is body. That is the date that the client wants to transport to server, and with technical upgrade, we will have HTTP2. So this is the HTTP1 package, and for nowadays, we usually use HTTP2. HTTP2 was developed by the Internet Engineer Task Force HTTP Working Group, which included contributors from various organizations, including major technology companies like Google, Microsoft, Mozilla, and others. HTTP2 was designed to address the limitation and inefficiencies of the original HTTP1 protocol, aiming to improve web performance and enable more efficient use of network resources. HTTP2 has many better features than HTTP1, as like the multiplexing and binary protocol. The former one allows multiple requests and response to be sent and received simultaneously over a single TCP connection. The later feature makes HTTP a binary protocol for framing and parsing messages. So this binary formatting is more efficient to process, reducing parsing overhead and improving performance. As a great features of HTTP2, we will not to tell here, and HTTP2 was officially standardized in May 2019 with the publication of RFC 7540. Since then, it has seen widespread adoption by web browsers, web servers, and content delivery networks. Okay, after going through this teddy task, here we have a client request. So all action of this step is make a client request. If we get a client request, so what is client request? So the client initiates the HTTP transaction by sending a request to the server. Yeah, all right. Okay, client send a request to server, and the server will process it. Upon receiving the request, the server processes it according to the specified HTTP method and the requested results. The server may perform various tasks such as retrieving data from a database, processing business logic, or generating a response dynamically. Yeah. Okay. After processing, server will make a response. Server response is after processing, the server constructs a HTTP response to send back to the client. This response includes a status line header and optionally a message body. The status line contains the HTTP version, the important one, a status code indicating the outcome of the request. For example, 200-200 for OK and 404-404 for not found, and a brief textual description of the status. Okay, the next one, the client will process this response and process it according to the HTTP status code and any other headers included in the response. Okay, depending on the status code, the client may render the received content, display an error message, or take other appropriate actions. And sometimes there will be optional additional requests. Okay, in some cases, the client may need to make additional requests to fetch the supplementary resources, for example, images, scripts, style sheets referenced in the initial response. This may involve sending multiple HTTP requests in a sequence to retrieve all necessary resources. A special example is like usually if you want to develop your own website, you will the best choice is to save the big file as like images, sheets on image file. For the open source, I really like use the min.io. This is a tool for you to save your images, save your files online, and directly read by your website. So if we use this technique, the client will firstly get the page from server of the main page, and then from the main page code, the JavaScript code, and to read images, read any other things from the image server, maybe different server in AWS or Azure cloud. Okay, that is the optional additional request. Okay, when the client and the server finish all their process, they will do termination. Once the next necessary resources have been retrieved and processed, the HTTP transaction is complete, and the connection between the client and the server may be terminated, depending on factors such as HTTP keep live setting. Okay, I think you will already have the basic idea about HTTP. Then let's go back to our question. Okay, the first one, there is the application, and this is the API service. The first line, the message one. Message one is the client gave a request about the user get method and choose the results of version 1 API data size 1, 2, 3. Maybe on the front is the API server's host name and port, but it is hidden. Anyway, okay. Okay, the stack message is the server server side, we are using HTTP 1.1. Okay, HTTP 1. That's fine. Okay, and the response code is 200. That means okay, this resource is good and no authentication or authorization error. Everything is okay. The last modifier is that this data 123 data of 123 last modified at at this date. We can see this is 9th February 2020. Okay, the 12 o'clock GMT. And another message is the ETag. ETag, blah 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 blah. Okay, the HTTP ETag. What is the HTTP ETag? HTTP ETag is the mechanism used for web cache, validation, and resource identification in HTTP. It's a part of the HTTP header sent by server. So this message is in which part of the response, the HTTP response package? The header. Okay. Yes, it's a part of the HTTP header sent by the server along with a result such as web page, image, or file, and in response to a client's request. An ETag is a Unicode identifier assigned by the server to represent a specific version of the results. When the client makes a request for a result, it includes the ETag value in the if not match header of its subsequent requests. The server then compares this ETag value with the current version of the results. If the ETag matches, okay, the server responds with a 304 not modified status code. So indicating that the client's cache copy of the results is still valid and the client can use this cache version without re-downloading the entire results listen entirely, re-downloading the entire results, re-downloading. So if this is matched as like the message string. This is the application. The client send get. Okay, the same URI and the header. In the header, there is a if non-match. Blah blah blah. So this is the 1740 and the 1740. This is the same, right? That means for this results, and the client asks the server that is it modified? Is it modified? And is it the new one, the newest one? Okay, the server said, yes, this is the newest one because the response code is 304. 304 means what? 304 means not modified. Yes, not modified. Okay. So this is the new one. If it is the new one, what should the client do? Yes, the client receives a message. The message 4. It is the new one. I have the newest one. I have the newest date. So I will not request this message from internet. That means the first line. Okay, the first line. This message, the first message will not include the real date, just maybe an empty package, the empty body, to send. This is good. You understand it's good. And the data is always this one, always this copy. So do it by yourself. And then the client copies the cache to the results to the application. That means which area the application will use this date. Copy the cache to the application and use the one on the client, not on server. Okay, ETags provide a lightweight mechanism for efficient cache validation and the results unnecessary data transfer between clients and servers. So if all the applications on the world use ETags, there may be receive many bandwidth, many network resource, many data storage resource. Yeah. Okay, the next one is the fifth. The fifth method is the client gets the same message again, and there is a tag of if modified things. Okay, that may be a data range in the option. So when the client sends a request with a if modified things header, it indicates to the server that it only wants to receive the request results if it has been modified since the specified date and time. If the results has not been modified since that time step, the server responds with a 304 later code instead of returning the entire results. So this response informs the client that its cached copy of the results is still valid, and the client can continue to use it without re-downloading the entire results. So in this message, a client gives the if modified things. Since is the 9th of February 2020. Okay, the 11 o'clock. 11 o'clock is before 12 o'clock. All right. So if the time point is from the 11 o'clock and from 11 o'clock, and is it be modified? Yes, it's been modified at 12 o'clock, 1 hour later. So if client sends this message, server will check from 9 o'clock. It will be modified. Yes, it will be modified. Then send all entire body, entire message, entire date to the client. So is this the entire date? Yes. Is this the entire date? No. Is this the entire date? Yes. Okay. Let me go back to our options. So option A, message 3 and 5 are equivalent to 3 and 5. No, the header option is not the same. The first one is if non-match. The second one is if modified since okay. So it is the wrong option. Yes. The second one, option B. A particular date set was transmitted to the client in message 4. In message 4 is any entire date? It's any date? No, no date. Just a notification, no date. So partial date set. It's a wrong description. So this is wrong. Okay, the option C, the full date set was transmitted to the client twice. First one, 200 is means transmitted the entire data. Alright. First one, the second one, message 2 and message 6. Okay, C is right. The option D, the date set didn't change during the scenario. I think yes. There, the date set just be modified here, and from message 1 to message 6, is the only one changes the date set? No, not. Because what is the year today? 2024. Alright, I can also use this one and maybe also the same results before, because this date is just it's only being changed, being modified at in the 2020. Okay. Okay, the last one, option E. The date set changes sometime between message 4 and 5. Yes, it is. No, it is wrong. Yeah, not changed. So if the option D is correct and the E is wrong. Alright. So for this question, the correct answer is C and D. Okay, as a summary of today's class, if you want to study HTTP as a Devnet engineer, firstly, you'd better to understanding of the HTTP protocols, and second key point is HTTP methods as like get, post, put, delete, patch, options, and head. And the third one is the HTTP headers, and learning the most methods of the headers that like the priority of content tab, accept the user agent, and cache control. And then you should better study the state code, like which is the 200, which means of the 200 and the 404, 403, 401, 500. And then you'd better to understand the URL structure, URL, URI, and then the statelessness. And next is the security consideration as the CSRF. The last is the performance optimization, like HTTP, HTTP2, and also API document and interaction. Okay, and find some tools and libraries as like the Python library requests, the fast API will help you to study HTTP well. Okay, thank you all for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day!